Good evening, everyone. Welcome here at the Eindhoven Innovation Café. Very nice that you are all here. For those of you who haven't been here before, we are a weekly networking event where we offer presentations on the subjects of technology and design. Today we have Yari Foelen here. We'll talk about Useeble.
Useeble, yeah, that's right.
Which is about responsive materials. So yeah, enjoy the talk. Afterwards we have the opportunity to have drinks and continue talking about it. Maybe also the dinner table, but I'll tell you a bit more about that first. But the floor is yours.
Okay, well, thank you Anouk for the kind introduction. As you can see or heard already, my name is Yari Foelen. I'm working currently at TU Eindhoven, and we're in the process of founding the startup called Useeble. I have conducted my PhD research. Recently I finished that, and with the technology we developed during my PhD work, we now want to bring smart stickers to the market. So, smart stickers, what should they do? Are they fancy electronics? Well, no. For us, the smart thing is really inherently in the material. So what we want to do is follow the temperature exposure over time. Basically record temperature that's been endured during the lifetime of a product, and we want to do this by an irreversible color change. As an analogy, I'd like to use ice cream melting. The ice cream melts faster the hotter the environmental temperature is, and if you cool it back down, it will stay basically in the same state, heat it back up, and it starts melting faster again. And we want to emulate this type of behavior by a color change, preferably something that goes from green, indicating good condition, to red, indicating basically that your quality has degraded. So once again, imagine ice cream in a box and you want to ship it. Once it arrives at your home, you have basically zero clue what happened during its lifetime. So the melting starts above 0 degrees. So from that threshold temperature, you really want to ensure if your product has been exposed to temperature or not. So over its lifetime, it goes through the chain until it reaches you as a customer, but you have no idea how did it experience the travel to here. Well, if you would put on a sticker of us on the box, there it is. Then, during its lifetime, you would see, okay, the temperature has been breached, but it's still fine. But then, during B2B transfer, something went wrong, basically, and you can already see that it discolors a little bit. This can already warn you in the process that the product might have been violated. And then, even more unfortunate, your ice cream gets delivered at home, but nobody's there, so it sits there in the sun. And basically, then the indicator should indicate that the quality has been completely lost. So if we then take all these different breaches of temperature, we can basically accumulate the thermal energy that the product has endured. And this we can then formulate as a certain amount of kilojoule. And this can be directly coupled to a crucial quality loss of your product. So for instance, temperature can initiate bacterial growth, but also speed up ripening, or just overall material degradation. And this we want to couple exactly to the rate of our color change, going from green to red. So how do we get this color change? Is it it's not, let's say, a display that changes, it's really the material that changes. And it's not a normal dye. We do it a different way. We do it by using liquid crystals. And now you see chemistry on the screen. I know that not everyone is a chemist, but basically what you need to know is we use liquid crystals. This is a very typical molecule because it can reflect color. So if we then go and zoom out, we can basically imagine this being rod-shaped. And the special thing about liquid crystals is that along the molecular direction, there's a different interaction with light than perpendicular to it. So if we then order these molecules periodically, we get a constructive interference of light, and that way we get a structural color effect, meaning the constructive interference really reflects one specific color. And that's why we can print with transparent ink, and once it reaches the right kind of order, you see a colored material on your substrate. This colored material, by modifying the chemistry, we can make it responsive, and we can make the color change by changing the order. In this case, we can go from green towards blue by decreasing the order or the pitch that you see here, and if we increase it, you get your color shift towards red. If you really lose all the order, you go colorless. So that's also a color change. You go from a colored state to a transparent or scattering state. To really exemplify this, this is a coating that's initially blue, and we chemically modified it to absorb in different ways when it's exposed to water. So here really the water will go in and stretch the order. So yeah, now you see it works very instantly. Your material swells, but let's say, what we don't like about this is that once you remove the water, so once you expose it to heat, the water evaporates, so you go back to blue. So this is a reversible process, or a reversible color change. During my PhD, our whole game basically was to make the color change irreversible. And luckily we achieved this. So here you see a green printed coating, just a square of a few centimeters. And when we expose it to temperature, this is now a 2-hour time lapse, you basically get a color change, going from green to red. So in the graph, this is set as a color change over time. And when we do this for different temperatures, then we need to zoom out on the time plot. But this one is the one from 60 degrees. But if we expose it to 40 degrees or 20 degrees, we see that the rate of color change rapidly decreases. And we take a very much longer time for color change. And so this makes this material time dependent or rate dependent to temperature, and this is called time temperature integrator because it really integrates the temperature exposure over time. And so, yeah, now why do we love this technology this much that we want to build a company around it? Well, we can really tune it down to the molecular level, so we can program it to be a desired color change, but also a desired time and temperature response. So we can make product-specific indicators based on the formula of our ink. It's, of course, totally battery-free. It's inherently in the material because it's based on a physico-chemical interaction that we can program. And it's printable, so we can do high-throughput production, driving down the cost. And also we can print on plastics, so it's easy to integrate in packaging materials. So we loved it that much that we also patented it. So it will be the core technology of our soon-to-be company. So now I want to invite you also to think along and to be creative. For the next part of the talk, I will talk about potential applications for this technology. And what we think, where we think that there's many advantages of using these thermal history indicators. So I will go from higher temperature applications down towards cold chain applications. This is also kind of the approach that we want to do when we go to market, because for cold chain applications there's also many regulations which mean a longer time to market. So that's why we choose this approach. So the first one is to track thermal processes and validate if they reach the right temperature, the right time, or if the temperature was going over the critical temperature. So for instance, in bioreactors, but also in sterilization processes where there are already a lot of indicators used to really validate if the right conditions for sterilization have been met. Another one is to monitor batteries, because nowadays for grid stabilization there's these battery units inside containers. They get shipped all over the world where they need to stabilize the grid. And they lose drastically their capacity on a cell-by-cell base once they heat over 40 degrees Celsius. And this is very hard to control or to inspect. So if you would supply these individual cells with an indicator, you can already detect in a very early stage if quality degradation is occurring or not. So that was more of the process tracking, but then you also have product degradation tracking. So of course comes to mind sensitive chemical products or pharmaceutical products like vaccines or insulin or other type of medicine basically. But also towards food and beverages, for instance quality wines. Once during transport a wine experiences temperatures above 30 degrees for longer times, your wine will turn turbid and you will also have a quality loss in terms of the taste. So to really have this as a quality label on your bottle of wine or on the box of wine, this can make a fancy gimmick basically also in the luxury market. And there's also another luxury market that's very sensitive to temperatures. That is luxury chocolates, because chocolate melts, we all know it. But for these very fancy ones that use many layers of different types of taste and so on, if you would supply these boxes with an indicator, you can have a nice certificate of quality basically as an additional feature. A big market in the Netherlands is the flower market. So it's very crucial. Once the flower has been cut, basically, it starts dying. So then the rate of deterioration is very temperature dependent. And if you would enable to visualize the temperature that it has been exposed to, you can also plan your logistics based on the time left in good condition. And then we can really move on to let's say the biggest market in the end is for food labels. So if you are able to track the temperature exposure over time for your food products, you should be able to replace the traditional expiration dates, because they are just forming an estimate based on the temperature exposure of your product. But if you would have these smart indicators, you can really couple this to the degradation of your product and be more sure about the quality of your food product. And we only see advantages for all parties in the chain. So for the consumer, there's an increased trust in the brand that they buy, because they can be more sure that their food is safe. So you really give the consumer insight in the, let's say, the lifetime of the product. And it also allows for better management at home. Once you open your fridge, sometimes I cannot even find the expiration date. If you would just have a clear label with a color indication that's saying green, go, or red, expired, you can already instantly estimate if you want to use a product or not. So when you see something in your fridge that is already with a yellow label, you're more prone to use it actually before throwing it out. So that's for the consumer side, but also from a business perspective, you can reduce massively the amount of food waste that's happening nowadays. And one of the key features is that you can transform your logistics again from instead of first in, first out to first expired, first out. because already in your warehouse you can see if you need to move your products to the retailer because they have been harmed somewhere down the transport or somewhere down the chain. But also at the retailer itself, by using these indicators, it allows the retailer to really use dynamic pricing. That's something you already see in Albert Heijn. On the date of expiration, they put a 30% discount. But if you can already see 1 or 2 days before, you can minimize the discount, but still get your products out before they're totally expired. So basically, those are the applications that we have in mind for this technology by now. Our main aim at the moment is doing the technology development, so really maximize the temperature and the time component and really control it so that we can, in the end, program it to be product specific. So yeah, we would like to drive it down to 0 degrees or even below 0 degrees for the response, and then really control it between minutes and days, the way that we formulate the ink. And to do this, I'm working on this with a beautiful team. I have my professor from the PhD as my main advisor on the technology. Some of the team are here today. I have Marco as a brilliant liquid crystal chemist. He is also supported by another brilliant person, Johan Leub. He was working for Philips in the past. Also Janneke, she is putting all the effort into coating characterization. And I also have Anna, who is further developing these indicators. So aside from Eindhoven and the support of the gate, I'm also in the establishing collaboration with the University of Wageningen, as they have a food technology group. And also I'm part of the Faculty of Impact, which aims to bring academic innovations onto the market and make them a commercial success. So with that, I want to thank everybody in my team. I want also to thank everybody present here today, and also, of course, the people of Innovation Café for hosting this event. Thank you, and I invite you for questions and ideas. Yeah, he was first.
You showed about with the water, then the crystal expands a little bit, so the wavelength that reflects changes from green to red.
Mm-hmm.
And I can imagine if you raise the temperature, also the crystal expands a little bit, so it shifts. But you remove the water, then it shifts back.
Yeah.
And for me, it seems the same with temperature. If you lower the temperature again,
Mm-hmm.
it will shrink again, so it will become green again. So can you tell a little bit? I know it's patented, I promise.
Yeah, no.
How does the crystal, after getting in a bit of energy,
Mm-hmm.
how does the crystal stay in its current state? And does it fall back? How do you guarantee that?
Yeah, they asked me to repeat the question for people at home, but basically the question is why does, after exposure to thermal energy, it not basically return back to the original state? So the thermal energy absorbed causes a sort of a relaxation in the material, and because we also have, I'm thinking now also to not give away too much, but we also have some, as I said, physical-chemical interactions that also prevent the initial state from ever coming back, because basically I was telling the story about the order that you put in. So after thermal exposure, you lose order in some way, and that order cannot be regained. You cannot put it back into the system. So it's, it's foolproof, let's say. Yes, next.
I have 2.5 questions.
Okay.
So, do you see a chance to make this irreversibility, to design a sticker such that I can see the temperature profile over time, like something diffusing through the sticker when I activate it, and then I see when the temperature has been exceeded. Is that within reach with this technology? Can you just tell me testing about the temperature?
Yeah, so to summarize, your question was if you can really calculate back the history, basically, of the
Yeah, so
temperature
maybe I want to see
exposure.
a color profile, you know, so
Yeah.
I activate the sticker,
Yeah,
then I see a color profile
Yeah.
after 24 hours that reflects the temperature.
Yeah. So in a way, you could already tell, you can tell up front how long it takes for the color transition. And the other, so based on diffusion, that's basically the same as happening, because you cannot know when in time the breach was. You can only tell how long it was.
Yeah, so you can't envision a sticker that would tell me.
You mean with timestamps, you mean?
Yes.
No, but I'm not sure that there's a material available that can perform this, because you need some electronic component to really record the timestamps then.
Yeah, well, that is maybe afterwards.
Okay. Yeah.
And the other question is, so you don't have to activate the sticker?
No.
So you have to keep it cool?
Yeah, that's right. That's
and
right.
What confused me a bit, so how does it help me with my food in the fridge? Because my fridge is cold, I know that.
Yeah.
So it also changes color over time, constant temperature.
Yeah.
So it's also kind of simply a clock.
Exactly. So so in the first example where I have 60, 40 and 20 degrees, at 20 degrees it takes over 30 days for a very visible color change. So even at low temperatures you can have this color change.
What I'm wondering, I'm asking because my question is related. Like, for example, every product has a different expiration dates. So how this can be manageable with the situation? For example, it's super basic sample, but like an apple is different, a meat is different. Like super basic,
that's true.
But like a drink is also.
Yeah, for sure. But basically for all these products you have a packaging and most of the time a wrap printed around the packaging that gives you the information. And so we propose to also just print on that one for that product specific. We aim to be able to formulate an ink product specific. So that's one of the core strengths of this technology, is that we would be able to very quickly formulate specific recipes, while alternatives like the one mentioned here that diffuse, they are depending on multiple components, because you need the diffusion layer, you need the dye, and they are harder, or it takes more effort to really tune them product specifically.
Yeah, I have a question related to that.
Yeah.
You're going to make different formulations for different products, obviously. One product degrades quicker with increasing temperature also than other products, for example. And will you be able to remake those inks very easily? Because you have to make a certain batch of ink. You use it for a certain range of products, and then maybe a year later you need make the same ink. Is there a thought about that production process?
Are you asking, okay, yeah, I see. So you're not asking about the stability over time of the inks. Okay, yeah, that's true. Then you would really you're really required to make each time a new batch. That is true. But we're trying to keep let's say the components as low as possible. So it should be feasible. If you're really only focused on ink production, I think different formulations should be manageable.
Okay, so you have an idea about the production process of all the inks
Yeah.
at that time?
Could you make this like a printer with an extruder where you make every sticker different for a different time?
So then you would use like a cartridge to tune the formulation, something like that. Yeah, it could be possible. Yeah.
So that you don't have a big batch of ink sitting around.
Yeah.
You use it only the moment the sticker is running.
Exactly. You could also work, with pre-mixtures and then, Oh, there's. Yes. Yeah.
I think we are building question upon question upon question. In terms of, you said storage, like, okay, you need to have batches. How do you keep, because once you produce it, how do you know when the quote-unquote timer of your material, is that something that you can set? Like, okay, from now on, be active, or is that in the solution, in the fluid itself? Because if you create it on day 0, but you only put it on product 3 months later, for instance, or any time later, not day 0, how does the fluid change? Does it change, or does it get activated?
Yeah, so that's a good question. And basically there are 2 options. Either you equip your production line that already now puts on expiration date, you equip it with our technology, so we also have then to introduce hardware into our manufacturing and into our technology. But so you can then directly print, and then you also are 100% sure from the moment it's packaged, it's being measured. The other one is that we would produce indicators and distribute them, and from the moment of distribution, you have to keep them at a cold in a cold chain, and basically, then you would provide your batch of indicators with an indicator to be sure that they stay chill. Yeah. There was a question in front. Oh, okay.
But I had another one.
Yeah.
So the main idea of the company is to do temperature, right? So
Yeah.
the example of the humidity is not there now. Do you foresee that as something also to look into? So humidity responsive labels?
Not in the first, let's say, first iteration of the technology, no. At the moment, we're really focused on temperature because that can be directly correlated to bacterial growth or material degradation or, other processes, because it's always coupled to temperature. So it's one of the best proxies you can have for your quality loss. Yes?
I saw a question in the chat.
Okay.
Can you put it on screen? So Audrey asks, if my food experiences say 50 degrees but only for a few seconds, will the indicator respond, and is the food really damaged?
Oh, that's a good question. Thank you, Audrey. Let's say that we want to be able to program these indicators that they allow for a high temperature exposure for short times. But of course, you will see that there was an exposure because, as I said, it integrates the thermal energy. So it really depends on how long that you expose it to 50 degrees. But I'm not sure if you leave your food in 50 degrees, for instance, in a hot car, for a few minutes already. If you then want to still consume it after a few days, I would not recommend that anyway. So I hope that answers the question. It basically comes down to being able to program this and prevent this. Oh, I see another one.
You've got another one going.
As sustainability is more and more important in industry, is it possible to code this technology solvent-free? Oh, that's someone who already knows a bit more, because I never talked about solvents. It should be able to code them solvent-free. So, short answer.
How do they decompose? How do the stickers?
You are able to solubilize them, but not in, let's say, pure water. They won't solubilize. But if you add some things to water or use different solvents, you can solubilize them back from the substrate. So, but then they're gone, basically.
Yeah.
You cannot regain.
Well, I dispose them off in the trash.
It's so it's a polymer ink. So,
I have a question.
Yeah.
The sticker, so this is measuring temperature, but then I put it on the outside of the packaging.
Mm-hmm.
So what is it measuring? Is it like measuring the outside air temperature, or is it measuring the packaging temperature?
Yeah.
Because I mean, if the product itself is exposed to, like, say, 50 seconds to a hot temperature outside, it does not really make sense. Because if the product is inside, like, insulated packaging, so then the inside temperature of the packaging would remain constant.
Yeah, so exactly, you have to calibrate for the position of the indicator compared to the actual product. So the best thing, of course, is to get the indicator as close to the product as possible. I lost my thoughts. You can really also, so basically if you put it on a surface against your product, it will resemble the actual product temperature as close as possible. And also, if the environmental temperature starts heating up, let's say the outside of the packaging, also on the inside, the outside of your actual product will increase in temperature. And so for instance, for food products or things that are in the cold chain, bacterial growth starts also most often already on the outside of the product. So that's actually also what you want to simulate. Yeah.
Are there stickers used already now, or is it still kind of pre-production phase?
Our technology is still pre-production, yeah. We're now working hard on TRL level and so on. But yeah, there are alternatives based on dyes that degrade or decompose. But most of these dyes, because the dye is a very small molecule, they're not food safe. And we are using polymers. I cannot guarantee yet that they will be FDA compliant, but we assume we have a higher chance than just a small molecular ink.
Do you have an estimated time on the first industries will use it?
Yeah, that's a very good question. Yeah, I'd say.
I prefer telling them that during the drinks.
Yeah, rather sooner than later is the answer.
What's your what's your aim for the first batch? I think it's business to business already to consumer.
Business to business for sure. Yeah.
At which technology readiness level are you?
Sorry.
Since you mentioned TRL, at which
readiness level are you? It depends on high temperatures. We are now TRL 6, but for cold chain applications, it's rather TRL 4. Yeah. Oh, I still have a question there.
It's on the outside of the package, right? Is it still the FDA approved?
Yeah, in that case, no. Yeah, well, I'm not sure. I think for packaging materials, there are also regulations to which you can or cannot use. But we're first aiming for higher temperature applications, and then we hope to survive and make it to cold chain applications. Okay, again, a question from Arne. Do you want to aim for the style? Yeah, it's basically what I just said. So high temperature applications, thermal process validation like bioreactors or steam sterilization, these type of things.
I have one more question.
Yeah.
So what I understand is, like, we have a base temperature where there is like a specific color for the material, and then like if the temperature increases, then the color changes. So I see that this is only like one directional, but then is there also like material changes its color when the temperature reduces? Say we start at 20 degrees and then it goes to minus 10 and then it comes back to 20. Is it possible to record that change?
So you want to know if you can also have a lower temperature measurement instead of breach. With our technology, you can only see when it breaches a temperature. So not when, you also have lower critical temperature integrators, but that's not feasible with this technology.
I'm also curious about the business point of view. If you are introducing it to markets, what are the challenges you're facing in that?
It depends a lot of the market, of course. For instance, for these process validation type of things like steam sterilization, there's already many current alternatives. And because it's in the medical field and medical area, there's also, let's say, resistance to adoption of new innovative technologies. So yeah, it will be a bit of resistance. Also, when you go to cold chain applications, there have been some trials, especially in the Netherlands as well, to already use these time temperature integrators, and they all show a positive effect on consumer behavior. Also, something that might work in the long term in our benefit is that the European Union is now investigating if such time temperature indicators can really serve as a legitimate alternative for expiration labels. So once that advances further, there might be a huge opportunity opening up.
One last question.
Yeah. So will consumers need instructions on how to use the labels? Or that's a very nice question again, Audrey. So on the first, it's actually 3 questions. So the first question, so the indicators already on the market now, they also provide like an instruction, for instance, white is good, pink is bad. Oftentimes they are based on a dye, so they cannot really program the color change, and they cannot really work with this intuitive green to red color transition. And now I was going to go to the next question. Okay, thank you. So exactly, you can integrate a color scale that can already tell you like the certainty of the quality of your food, and these colors, if they will be affected by environmental lighting, basically no, they're not UV sensitive. And however, there is a component to them that makes them angular dependent. So if you're not looking perpendicular on the packaging, you get a shifted color. But yeah, that's something maybe to include in the instructions, that you should face it when you look at it. So yeah, that answers the 3 questions. Okay, thank you.
Well, thank you so much for your presentation and answering all so many questions. And also thanks for the people watching online for participating so much for joining in. Thank you all for being here. I warmly invite everyone to the bar for a few drinks. We'll provide some snacks as well. And if you're interested, you're also invited for the meetup table, which is a meal we offer to all of the guests of the Innovation Café. We offer that for €19.50. And that's today gnocchi with artichoke. I've heard from a colleague who's already had it that it's heavenly, it melts on your tongue. And we are here every Thursday at the same time. Check out the program for the upcoming weeks. Next week we have Bianca Karak here, who will be telling us about clothes she's making from human waste. So she uses hair to make clothes, which is a completely different subject again. So very welcome to come and check out the program on our website for the next weeks. So thanks.
Hey, you're still here. So you like the video. If you want, subscribe and click the bell.